Morning, children. So now today's class, we just have these two questions here. We'll start with this. What happens when tea is left for some time after being prepared? So if you've prepared tea, or if you've seen your mother preparing tea, you must have observed that after you finish preparing, you leave it for some time, then what happens? The tea leaves settle down, right? And the tea is on top, forms the top layer, isn't it? Even when your mother leaves the rice for some time after draining it, when she's cleaning the rice, okay, and drains the water out. Before the draining of water, that if she leaves it for some time, then what happens? Here also the same thing, or the rice will settle, form a lower layer, and then on top of that, water forms the layer above. This is what we are going to study today. We will be studying separation of solid substances from liquids. So we are going to study about separation of insoluble solids from liquids. Now here three processes are given. The first one we'll first concentrate on sedimentation, where mixture of sand and water is taken, and when you stir that mixture, you find that sand forms a lower layer and water forms another layer above it, right? All the sand particles, since they are heavier particles, they settle down, and there is a layer of water that is formed on top, and this water can be removed or separated in another beaker, another vessel. Okay, and that process of removing that upper layer of water into another beaker is termed as decantation, right? This is one method in which you can separate that solid sand from water or any insoluble solid from any other liquid. There is another process, but here we are not allowing it to settle down. So what we do is we stir it, okay, and then we use the method of filtration. Now in the method of filtration, you can see what are the things required. You require a beaker here to collect the filtrate, you require a funnel, and inside this funnel you can see this filter paper, okay, which is folded in cone shape and then placed in this funnel. The funnel is held by a stand. So now inside this funnel, when we pour this mixture of sand and water, what will happen? This filter paper will not allow water, sand to move down through the filter, right? It will only allow the water to pass through the filter. So in this beaker here, we collect the water, which is termed as the filtrate, okay? And in the tissue paper, the filter paper here, what we find is the sand particles, which is termed as the residue, okay? Now this is a water treatment plant, okay, where the sewage water is being treated. So when you go to such a plant, there also you find such huge tanks where water has been kept. The sewage water is simply kept for some time. And what is the process that is happening here is sedimentation. When the sewage comes, it has a lot of impurities, right? So when it is kept in these tanks for some time, all the solid impurities which are heavier, they settle down, and above we get a layer of water. Okay. So then this layer of water is removed from this tank through pipelines, and the settled impurities are taken for decomposition separately. And that's how they separate the water and the solid impurities, and then each one is treated separately. Now the process of sedimentation can be you can say the speed of sedimentation would be increased by the process of loading. Loading, as the word itself tells you, that something is being added over, okay, or loaded, as you see. So what happens here is that we use a substance called alum, which is a very common substance. If the water is muddy and the particles are not settling down fast and you want clear water, so what is done is this alum is stirred in this water. Okay. So 2-3 times when you stir the alum and then remove the alum from it and leave the water like. So what happens? These alum particles, they dissolve in water. Okay, and on these alum particles, very fine dust which was not heavy enough to settle down, Okay, so all these dust particles, they settle on the alum particles, okay, thereby making it heavy. And then once it becomes heavy, they form a layer of sediment on the lower surface. This process, in a way, is to make the lighter particles heavy. Okay. Unless and until the particles are of a particular size or are a little heavy, they will not form sediments or they will not settle down on the lower layer. So to increase that process, you can say the particles are very fine, it might take a very long time for them to settle down. Okay. So to increase the speed of that process or to help in settling down the particles, we use substances like alum, and the process is termed as loading because the dust particles, they load themselves on the alum particles. Okay. Now osmosis is another process where substances move across a membrane. Like in filtration, we had water molecules moving through the filter paper. But in case of osmosis, it's another method where water molecules are moving, but they move across a membrane. Okay. Here, there's no filtration as such. It's like the water molecules move from a place where they are more in number to a place where they are less. Like you can see in this picture here. Salt molecules are more here. In a way, same number of salt molecules and water molecules. But here, comparatively, water molecules are more. So what happens? The water molecules from here start moving to the other side to make the, you can say, number of molecules same on both sides. This process is termed as osmosis. Now, there is another process called reverse osmosis. According to the word, reverse means water is sent back. Whatever water had shifted is sent back. But this cannot happen naturally. So this is done by applying pressure, by pushing the water molecules back. You can see here salt water and fresh water. Salt water will have salt and water molecules, so water molecules will be less. Whereas here in fresh water, only water molecules are there. So actually, if you go to see water should move from fresh water to salt water, but we don't want that. We want water to move in the opposite direction. So we apply pressure, and water moves from salt water side to the fresh water side. This is happening. Natural osmosis would be from fresh water to salt water. Okay, and we are applying pressure and reversing the natural process. So it is termed as reverse osmosis. This is something which you must have heard as RO in your water filter. Okay, this is the process of filtration which is used in the electric filters that you use at home. Okay, this reverse osmosis is very common. Here we have two questions for you to think. Find the practical application of reverse osmosis, where it is used, explain it, and explain the process of loading. So to work on these two questions, we will meet in the next class. Thank you, children.